And there you go.
All right, welcome everyone to the Brisbane Azure User Group for December. So we're just wrapping up the year. We've got 2 great presentations lined up for us just after a bit of news roundup. So I'm just going to kick on in and get right into it. So before we go too far, we really need to put a big thank you out to our sponsors. So our sponsors have been fantastic as always. So Codify and Microsoft, they've been there for this group for years, so they're fantastic. So all I can say, they're awesome. Tonight we've got a double header. So we've got exposing legacy apps with Azure Relay, and a new feature that dropped in build, so serverless K8s with Azure Container Apps, which looks pretty cool. And Dan, we're after some more people for January, I believe.
Yeah, well, if we have no one else, I can probably do a wrap up of integration updates that came out of Ignite. But definitely, if we got somebody else lined up, then you don't have to listen to me talk. That would be.
So everyone that doesn't want to listen to Dan, put your hand up, put your name forward, and give a bit of a presentation. It'll be definitely welcomed with open arms. We'd love to hear from you. Before that, I'm going to throw it over to Dan. We've got a job opportunity that we want to plug. So Dan, take it away.
Absolutely. Look, if you're looking for a new adventure and you've got any of those key skills of interest that are listed on this slide, which includes Azure and also C# and .NET, we've got lots of work at Deloitte and lots of interesting opportunities. So reach out. A second. There we go. Yeah, absolutely. You can scan that barcode or send a message to remcdonald@deloitte.com.au, or even just reach out to me. Send me a message on Meetup, on the Meetup chat. That's fine. I'll put you in touch.
Fantastic. Awesome. So a few updates. We'll lead it with this one. So there's a couple of new data centers for Azure coming online. They're green data centers. They're using new cooling techniques, which I thought was pretty interesting. So up to 90% less water in cooling these new Azure data centers. I thought that was pretty interesting. So they're pretty cool in Wyoming. A couple of new VMs have dropped. So they're quite sizable. This one here, it's got 96 CPU cores. It's got 8 80 gigabyte NVIDIA video cards, 200 gigabit per second network between the VMs and then back onto the Azure network at 40 gigabits per second. So it's pretty crazy. They're massive computers, so check it out. Probably don't run it for too long. We got Azure Web Pub Sub. Now this came out a while ago in preview, so it's a bit of a serverless offering. It allows you to do pub sub on the web. It looks pretty cool. So high availability serverless pub sub. Sorry about that. That's highly available. It is now available. So previously it wasn't available in Australia East. It's now available in Australia East. So check it out. It's pretty cool. There's a couple of virtual WEM updates. So packet capturing, a couple of topologies that are now supported. They just came through pretty recently. As well as something that's pretty cool is like the backup AAD authentication. There's a few things to sort of note about this. It's not full feature parity with the primary. In the backup, it allows to reserve up sessions that have been created within, I think it's the last 3 days off the top of my memory. But if the main AAD authentication service for Azure goes down, this one here is available, and I think it serves like 97% of customer traffic falls into the scenario where it would operate seamlessly for them. There's a few things to look into, but it looks pretty cool. You don't actually have to do anything. This is just a feature in Azure. Then Azure load testing is a cool new feature that's dropped. So it allows you to run JMeter scripts. It provides all the infrastructure and all that sort of stuff, and all the results feedback through into Azure Monitor. Gives you great metrics, all run in the cloud. Simple and easy to do. If anyone's done any load testing, they'll know that it's not always a simple experience, but this one's a lot better. And I think finally we've got some updates. It allows you to get automated emails out of your cost analytic views. So pretty handy if you want to get some weekly or triggered emails with all of that information. You can go down to a resource group or subscription or anything like that. So it's pretty cool. All right, so a couple of things that we like to plug is we've got a Slack channel for the people who are interested in Azure. We've got a YouTube channel, so this presentation is going to be up on YouTube. Normally it's about a week after. A few great learning sites, so 30 Days to Learn It, Pluralsight, Obscurity. They've got some great Azure content, check it out. These are the blogs that I like, so if you're interested in Azure, check out these blogs, they're pretty cool. All right, and tonight, without any further ado, what we're going to do is we're going to introduce Andrew and we're going to introduce Todd, and then I'm going to flick it over to Andrew. So Andrew Hardy, he is doing a fantastic talk about WCF, and I know Dan has done a lot of work in this space as well to broker WCF connections. Andrew Hardy, C# developer located in Brisbane, Australia. He's got 18 years of experience building desktop, mobile, web applications with .NET backends. He's had a lot of work in high volume purchasing platforms and statewide health systems. So welcome, Andrew, and great to see you first presentation. So that's great to see.
Thanks, Sammy.
And we've got Todd. So Todd's an old veteran. He's our sponsor here in the Azure group. Works for Microsoft as a cloud solution architect in the enterprise partner group. He's going to give us a great introduction. I'm looking forward to this one. So the Azure Container Apps is a new service that dropped not that long ago, was it, Todd? Like, yeah. Weeks ago?
It was weeks, which is years in cloud time.
Years, yeah, weeks, which is years. So if anyone's out there using Kubernetes and struggling with some of the heavier configuration stuff, this might be a good option to do Kubernetes-esque things without the overhead. So I'm going to throw it over there. Oh, sorry, tongue-tied. Throw it over to you, Andrew. Let me switch my screen, and welcome.
All right. Thank you. All right. So we're going a little old school today. And I'm going to be, like we said, talking about exposing legacy on-prem WCFs via Azure Relay. We still find WCF services everywhere, particularly in government, large enterprises, and they still fit quite well with a couple of architectures that are out there as well. So they're not going away as much as some people would, want them to. But the particular scenario that I'll be talking about today is, say you've been contracted by someone who has the on-prem WCF and they're trying to go more modern and get in the cloud, basically, but they just can't or won't move their on-prem WCF services. Now, obviously, sure, set your firewall up, let it through. It's all going to work, right? But maybe for a dev or a test environment, that's just not practical. Or maybe you need to do a proof of concept in engaging, other teams for firewalls, and that is just not going to happen, or it's going to slow things down. So the Azure Relay can come in handy. You can be up and running, within 10 minutes if you know what you're doing, Yeah, so in this scenario, we've set some modern app which has some DLL, some client, some website API that's going to go through the relay. That's going to go through the firewall, and now if you've got one down to the WCS service, and the reply is going to come back. So it's going to go in and out. For my demo here, I will run a WCF service in IIS on my box, representing on-prem, and we'll run just a console app in the cloud as well as on my PC. So I'll show both. So in the demo, we'll just have a quick look at the really simple client-server app that I put together. We'll look really quickly about how we go about creating the relay in Azure. Point and click, I'll take you through that, very simple. And then how we reconfigure the server in the client. So here, where the focus is on reconfiguring. If you're being contracted and this WCF service is 10, 15 years old, chances are code doesn't exist anymore. Don't really want to reverse engineer it and recompile it. You don't have to. WCF is one of its sort of more powerful features is its configurability, and we'll just be able to reconfigure to do whatever we want, basically. So yeah, I'll just sort of jump into it now. We'll jump over to Visual Studio 2019 that I've got here for representing my legacy. We've just got a should be .NET 4.6.1 ASP.NET in an IIS sort of application. It's running my IIS, like I said. It's just got a simple method at the moment, greet, just basically an echo. It'll just echo back and say hello, whoever you are. And then for my client application, again, not very interesting either. Just while through, push enter, and you'll be able to sort of talk to the server. So I'll just see if that's still working now. IIS hasn't gone to sleep on me. You should be able to. There we go. So it's just randomly Hubert, how you going, Hubert, and you can just sit here, obviously, and chat. That's all on localhost. That's all good. So it's representing the on-prem scenario. So actually, I didn't open my notes. One note over here. We'll just go through what we've got to do to get the client, this console app here running in the cloud, which is pretty easy to do in Azure, like most things are. Where did my browser go? So I've already created a VM, so we don't have to worry about that. That'll be where I'm going to run the client. And yeah, so we come into our RG, which I've created here. We search for something called Relay. Here we go. We'll create one of these. We'll create it. Yes, in my resource group. We'll call it demo Relay. Probably already exists. Yeah, of course it does. Don't really care where it is for now. Obviously, you'd pick that based on latency requirements that you want. That's all right for us. And we'll create this. Normally doesn't take very long to get up and running. These over here for the stuff. Need some elevator music. Okay. So I'd say, just to fill in time on while we're waiting for this, I've been doing WCF since it came into existence. Feels like a long time ago now. I'm still a real big fan of it. A lot of the time, when I hear arguments for, especially when REST came onto the landscape, why it was so much better and lightweight. I was doing a lot of mobile development at the time, and yes, it's great. JSON straight down to the phone. Phones back then couldn't deserialize large XML, let alone SOAP, just blow their little tiny memories that they had. But I do tend to get a lot of these arguments from people that are really unaware of a lot of the complex features that WCF offers, particularly logging and things like that. But REST obviously has come a long way since then. It's very competitive. All right, so we've got our relay started up. We just want to create a WCF relay in here. I'll just call it my service one. We want to relay HTTP traffic. I don't need Azure to do any authentication for me. You can just turn that off, pass it through, and do your authentication on the on-prem server, which is probably already enabled. And I have configured this for both basic as well as Windows auth scenarios and anonymous ones as well, like we'll be doing today. But yeah, you just turn that off and it just works the way it normally would. So we'll just create this very simply. You can give it any name you like, of course, and we'll come into the WCF relay that is here, that's been created. We see that there's no listeners, which is good, because we'll come back later and see this has been incremented once we've got our on-prem connected, and I can drill into it here, and we can see the actual URL, which is just a combination of my relay name that I created and the service name that I just created as well. So the first thing you do when reconfiguring a service, I have it here in the web config, is basically add a whole bunch of stuff that's probably not there. Okay, so the first thing we're going to do is add this basic HTTP relay binding, which is a bit of magic. Anyone who's just used the sort of vanilla WCF wouldn't have seen this one. And we'll actually jump onto Nugget to pull down a package from Microsoft that gives us that. The next thing that we would do is enable some extensions here. The client endpoint behavior for the service bus. This is the DLL that we're going to bring down, and then the basic HTTP relay binding, which is defined here. We're using what we defined here, which is simple. The next thing that we need to do, you may have multiple endpoints on-prem, multiple addresses. I've seen, obviously the default address here, but you generally have more than that. You might have an interoperable one for your Java clients. You may have a NetTCP one for your Windows clients, things like that. But we're just going to add another one. It's not too hard to do. In this case, the address that we will be picking is the one that I showed here before. So we'll just copy that one. That will be how we're exposing this service. Very simple. And then the last thing here is this endpoint behavior that we need to add. We need to give the service an access key so it can actually authenticate or register itself with Azure. Let's say that. So we can go back to our relay. We can go back to our relay here, go over to shared access policies, and we'll just create one of these and grab its primary key. That's the only thing we need to do. So in summary, really, these are the two important things: the URL here, the key there. Everything else that we uncommented basically supports the types that are defined here. So we would save that. I will manager so we can give it a bit of a kick. Can't remember the port that I've popped it on. Let's browse to that. Okay, so it looks good and healthy. Looks good and healthy because it's actually reading from a different folder. Let's publish this. Just publish it to my desktop. From my desktop. So this is our representation of our pre-built on-prem no source code application that we've got. And just because of permissions on my PC, I will just copy it into this slide here. Delete everything that's there. Yes, thank you. So that's just our reconfigured WCF service. Go back to here. And we've got an error straight away. Now this error is saying, I have no idea what this basic relay is. And like I said, we actually need to go to Nugget and get a package for that. If we go into the bin folder, I mean, it's going to be all the DLLs that we used to be there that are required to run the service, and we've just added another dependency. So it's easy enough to do. I will just find a link, sorry, on my other screen. So we'll just jump over to Nugget. This is the one we want, the Windows Azure Service Bus. Normally you would add a service reference, but we're pretending that we can't recompile here. So we would simply just download the package, find it here, and just open it in your favorite zip program, because that's all it really is anyway. And in the lib 462, this is the DLL that we want to add basically to our pre-existing website. So we'll just drag this one in. Yes, we want that. Yes, it does. Woohoo, we've got our WSDL here. If we jump down to the bottom in our bindings, we see that we've got the normal localhost one, but we've also got this additional port here with the URL that I specified. So that's great. All we need to do now is reconfigure our client. Here we go. If you had an existing client, this is what you do. If you're creating a brand new modern app, obviously it's very similar. You just wouldn't have anything to reconfigure. It will all be new. But we're replacing the normal localhost endpoint here with this special one here, which is again our link to the URL. The registered URL, which I'll just take from the WSDL, but it is the same as what was in the portal. Paste that one there. And we will run our app and see if it works all right. Oh, one thing that I forgot to check, or to demonstrate rather, is if you jump over to the portal, another link, we should see that listeners has been incremented that I mentioned earlier. I'm fairly confident that it's worked because we saw the endpoint in the URL, sorry, in the WSDL, we saw it there. But if I go to my WCF relays now, here we go, we've got our one listener, which is great. Run our client app. Press enter to talk to the server. Should have to think about it. It'll be a little bit of latency. There we go. So we're talking through Azure now. And to prove the point, what I will do is take this console app here, actually run it in Azure. I think I have, yes, I have IDP to the VM. Paste it up. And here we go. Right, so this is wonderful. What we've got now is some VM, somewhere in the States or in Europe, I forget where I created it, talking to my laptop here at home at Brisbane. So it's reaching all the way back down through that. I've done no configuration. I haven't opened any firewalls on my router at home or anything like that. And we can come in and you can see, well, it's fairly, it's just the latency between the locations. And that's it. That's how simple it is to reconfigure an existing app, no code changes required to talk to an on-prem WCF server. And the relay can do much more than this. It can load balance. You could register multiple servers, for performance issues. You will notice if it was, on LAN before, it is going to be a little bit slower, but there are ways to work around that. And this is a really good and easy way to, migrate older applications up to the cloud. At the end of my presentation, I just have to do a little plug at the end. Again, thanks for your time. I'm here representing CluedIn, and we're always looking out for talent in C# and the Azure space. So yeah, thanks for your time, Damien, and everyone else.
Thank you, Andrew. Any questions? Anyone out there got any questions for Andrew?
Go for it.
Kudos for a great presentation. Thanks, Andrew.
Welcome.
You can either come online, you can throw it in chat. If there's no questions, we might move on to Todd.
I think it was really good to see with the WCF. I recently did something with the hybrid connection manager, which basically helps you connect to the on-premise database. That also is something similar to what the WCF thing that Andrew has done.
Yeah, awesome. Thank you, Gupta.
Actually, Hybrid Connections is built on Azure Relay, which is the same exact technologies.
Alrighty, we might move along to Todd then. So if you guys think of any questions during Todd's presentation, feel free to drop it in the chat. But thank you very much, Andrew. That was awesome. So Todd, you're up.
Excellent. Thanks, mate. Let me just share my screen. All right. I'm hoping this is sharing. Hopefully you're seeing the right screen.
Yes.
Excellent, excellent, excellent. Yes, all right, thank you. So as Damien said, my name's Todd Whitehead. I'm a cloud solution architect in what's now called the App Innovation Team, because it's not a cloud thing if you don't change your team name terribly often. So I focus and help customers at an architecture level building all sorts of cloud native, modern style apps, and also migrating their existing apps to those platforms. So that's sort of my background. So tonight we're going to have a look at a new service on Azure. It's still in preview, and it is very, very fresh off the press, but it is in public preview, and it's as a developer, and I come from a developer background. It's very exciting. So I've called this talk Serverless Kubernetes because it's kind of the best way I can think to describe it. So let's just to set the scene. When we're talking about serverless and accepting all the t-shirts about it's always someone else's computer, from a serverless point of view, when we're developing apps, there may be servers there. We just don't care about them. We don't want to know about them. We certainly don't want to be billed by the server. We want a complete abstraction from that server. We also want scaling that is both instant and event-driven. So that obviously that could be a web request, but it could also be a message on a queue. It could be something happening on any service, really. We want that instantaneous scaling. And because we're the sort of people we are, we only actually want to pay for what we use. And this is the challenge to a lot of services. Although you get lots of scale in the cloud, the units that you scale at tend to be quite large. So you tend to go up and down in big chunks. So the ideal serverless sort of environment is one where we pay for what we use at a very granular level. And when you think of serverless on Azure, there's a ton of great services. Probably Functions is the first one you think of, which is serverless compute. But there's a lot of other great services. There's Logic App, which is serverless workflows and integration. There's API management, which actually has a serverless offering as well, which is great for API managing and doing all that kind of good stuff. And then obviously a whole lot of supporting services that make those things do their thing. So things like Cosmos DB, Event Grid, but also even things like Service Bus storage. Very, very cheap and very efficient at scale, building scalable solutions. And even things like container instances, which are already a serverless container offering. So really what I want to do tonight is have a look at this new service, but really make sure we kind of talk about where it fits and why you'd want to use it, because there's already a ton of places you can run containers in Azure. So why is this different and why is it so exciting? The reality is you don't even need containers to build good microservices. So we can take these serverless components we've got here and we can build and deploy a really effective serverless architecture for microservices. I mean, here's a really simple reference architecture we publish. And you can see this could be used for a wide range of services. And if anyone's ever seen any of Troy Hunt's great talks, he talks about how he redeveloped his website because it would literally go from almost no traffic to, he would get a mention on Oprah or something and all of a sudden he'd get 10 million hits. And that is an exponential scale that is really hard to manage when you're scaling in terms of servers or VMs. Okay, and serverless offers a much better way to do that. The downside for this sort of approach for microservices is there's a lot of management work you need to do. So the more microservices you deploy, so if they were deployed as functions in this example, you would have to configure your apps to know which other services to talk to. What are their URLs? Which version are they running? You need to manage all that sort of thing yourself. So really, you need some sort of way to orchestrate that complexity. And these days, whenever we talk of orchestration in any way, the answer always seems to be Kubernetes. Kubernetes is a container orchestrator, so that seems like a pretty viable solution for deploying microservices on, and it's one of the canonical use cases. And on Azure, obviously, we have Azure Kubernetes Service, which provides a managed Kubernetes cluster for you. But what's important to understand is Kubernetes is actually itself infrastructure. It isn't an app platform. Out of the box, when you deploy an AKS cluster, you can do it with a simple line of code, but it's a platform onto which you will build things. You will build apps, but you will also need to build a whole lot of operational readiness. So there is quite a steep learning curve, and it has been a challenge for a lot of people to adopt Kubernetes, to realize even when someone like Microsoft or AWS or Google or whoever provides the actual underlying Kubernetes parts, there's still a lot of work to do on top of that to deploy a secure, enterprise grade, scalable, safe, all those kind of things environment. Some of the work, and one of the great things about AKS and the way I think Microsoft have approached Kubernetes is that a lot of the projects, a lot of the features where they've needed to be added have been added as open source projects and donated to the community. So I wanted to especially highlight a couple which are going to become relevant later. So CADA, if you haven't heard of that, for example, is a way to help Kubernetes scale based on external events. So that could be something like the number of messages on a queue. It could be, and that queue could be an Azure queue. It could be a Kafka queue or a stream. It could be all sorts of things. So that's a way that Kubernetes can not just look at CPU and memory, which is kind of the traditional scaling levers, but other things. Another very cool thing is the virtual kubelet. So that's where you actually deploy, rather than a node being a VM in the cluster, it's actually a collection of those container instances. So you can almost think of it like a infinitely scalable node that's actually using those container instances. And the third project I want to call out is one called DAPA, the Distributed Application Runtime. So that's a way of simplifying how do you connect and leverage cloud services, and how do you build microservices without writing so much plumbing code and making them more portable. So they're open source community projects. They all integrate well with Kubernetes, but they're going to come into our story in a little bit. Now, as I said, once you deploy your Kubernetes cluster you're ready to build your microservices, there's still some more work to do. So this is just a little screenshot of a section from the Microsoft Reference Architecture Best Practices Guide. Here's all the decision points you have to decide on after you've deployed the cluster. So great, we've got a cluster, but we need to actually think about what networking model are we going to use on this cluster, because there's more than one. Everything in Kubernetes is pluggable. How are we going to deploy ingress resources? So how are we going to actually allow traffic into this cluster? That's actually a complex scenario. And you can see there's a whole lot of other things around secret management, monitoring, reporting, all those kind of things. They're all decisions you need to make, and then you need to layer those or configure Kubernetes to deliver that. So if we take a really simple example and go, okay, how are we actually going to allow traffic into our cluster? What we need to think about is quite a few moving pieces. So we need some kind of app gateway or load balancer or front door into the cluster, because Kubernetes doesn't provide one. It has the logical concept of one, but it actually doesn't provide an implementation of one. So that could be an Azure load balancer, or that could be an app gateway. It could be a whole lot of things, or it could be a controller that actually lives in the cluster. And there's a whole bunch of these you can choose from. And then you also need to think about how do you manage certificates to connect all those things together. And the best and the worst thing about Kubernetes is there's no shortage of choices. So people often, when they're deploying Kubernetes, then have to sort of process this. And if we think about that ingress scenario, you can see there in the service proxy section, what are we going to use? Are we going to use Envoy? Are we going to use Nginx? Are we going to use F5? Are we going to use Traffic? There's a whole bunch of open source and commercial offerings that we will then need to decide on, evaluate, configure, and manage and operate. This is before we can deploy any of our microservices. So there is immense power, but there's also a lot of complexity and overhead here that needs to be dealt with. And sometimes that's really warranted and useful and great. And sometimes, maybe we just want to deploy an application, which is what Azure Container Apps is all about. So think of Azure Container Apps as serverless Kubernetes, hence my talk, right? But it's this idea that I don't want to know that it's Kubernetes. And it is. It's all built on open source Kubernetes. Those things we saw before, things like CADA, DAPA, Envoy, that's what powers this, but you don't get to see it. Okay, you can't connect to the cluster with kubectl. You can't do anything you would typically do with managing a Kubernetes cluster. Azure Container Apps does that for you. All you do is deploy microservices, or you deploy onto it. Microservices being a great example, but there are other options as well we'll have a look at. And one of the great things with this is it's a serverless offering, which means it can scale to 0. So if there are no messages, no traffic arriving to your site, if there are no messages on the queue, it will scale all the way to 0. So we'll see as we go through. There's various ways you can configure whether or not you want that to happen and how you want to deal with it. But the fact that you can, I guess, is the big thing. So from a developer's point of view, this allows us to absolutely just focus on delivering apps. We don't need to, or in fact do know that it's Kubernetes. But because it is Kubernetes, we can very quickly take that application we've developed on and deployed on Azure Container Apps and deploy it to Kubernetes. So you get that portability of your application. If for whatever reason you need to move, might be because you want to run it in another environment, might be because you need to run it on-prem now. You can absolutely do that. So what are the big 3 ticket items? So as we said, it's flexible, it's serverless, it can support HTTP traffic as well as non-HTTP traffic. So if you've used Azure App Service, for example, a great service, can deploy containers, but it's specifically designed to handle web traffic. Whereas Azure App Containers is really a generic processing, just like you would do on Kubernetes. You can scale to 0, as I said, and it's basically has a whole lot of best practice, opinionated ways about how Kubernetes should be configured and run. You don't have to worry about that, but obviously that means you have less knobs and levers to play with. So if you want to tweak and control what the ingress controller is, this is not the service for you. Okay, this is opinionated and run on your behalf, and you just get to deploy in the apps. Obviously, developer productivity is a huge focus for this. And the other nice thing is there's obviously other PaaS or platform offerings around building apps. So even in Azure, you can think about there's Service Fabric, a great service for building microservices on, but it's built around a very particular programming model, a set of languages, and a set of runtimes. So that is not the case with Azure Container Apps. It's absolutely runtime agnostic. There's no required base container image. Run whatever containers you want. Use whatever runtime you want, use whatever language you want. There's no connection between what you're deploying and any specific requirements related to that. And as we mentioned, it's all built on those great open source projects we've spoken about. So all that experience and knowledge that have contributed to those projects, both from Microsoft and the open source community, is what's powering this and making this useful. So couple of scenarios what we can build with Azure Container Apps. So we've spoken about microservices, if you like, as already. And when we think about how we might scale those, that can be scaled on really any of the triggers, including any of the CADA triggers. So for example, if you've got some messages on a Kafka queue, you can use that as the way that the microservices scale. Or it can be by web traffic, which might be the more common scenario. But equally well, it might purely be event-driven processing. So this is, again, your messages and queues, not really related to things arriving in a HTTP sense. It's also great for exposing APIs, so endpoints, including the ability to do things like manage revisions, have multiple paths in, so that you can be running, for example, you might be doing some A/B testing or blue-green deployments or just doing rolling updates. It can manage all that for you out of the box. You don't need to go and track down any other services. And you may also have it purely as a background processing service. So just something that's sitting there going and processing database updates or doing something on a recurring basis. And that's another kind of really good scenario for it. So let's kind of jump to a hello world example of what this will look like. So, and we're going to do this first, and then I'll explain some of the concepts behind it. But let's just have a look what it is if you just wanted to do the hello world. So what we need to do, we don't create a cluster. We don't create anything to do with Kubernetes. We create what's very, very cleverly called an environment. So in this case, we're going to have what I'll call sample environment, and that's a security boundary. So everything in here shares the same virtual network, if you want to think about it that way. It shares the same logging and monitoring. And into that environment, we're going to deploy some apps. So in this
Sorry,
case,
Todd, you've gone a bit quiet.
Oh, have I? Sorry.
Unless that's just me.
How's that? Is that any better?
Yeah, that's much better.
Okay. Thanks.
Thanks.
Okay, so yeah, so into that environment we deploy apps. This is, I think the terminology is potentially a little confusing, but when we say apps, if we're talking about a microservice application, think of apps as a microservice. So in our particular example, we're going to have a front-end web application. Front-end web application written in Node. Okay, and it's the thing that's actually going to serve traffic from the web. And then we're going to have a back-end .NET application or microservice that Node app will call and return something to the user. So the Node app is the only one that's going to be exposed to the web. So we're going to have that as it's going to need some kind of ingress from the outside of the world. It's going to need HTTPS certificates. It's going to need an FQDN for people to hit as a URL, all that kind of stuff. The .NET app doesn't. We need it to be the Node app to be able to talk to it, but we don't want to expose that internal .NET app. So I'm showing you here just using the Azure CLI just because I think it reads a little easier, but obviously you can do this with ARM or Bicep or any other good scripting infrastructure as code type approach. And when we get to have a look at it running, that's how this was deployed using GitHub Actions. But the idea of this is just to show how, I guess, light and lean this is. All we're doing is creating a resource group, create a log analytics workspace, and then this immensely complex container app environment command. So we're just giving it a name, a resource group, the log analytics workspace, and a place to put it. Okay, so we're not telling it what version of Kubernetes to run. Big contrast to if you were spinning up something, you were spinning up an AKS cluster, that's one of the parameters you give it, which version of Kubernetes, because you need to worry about that. And you have to make sure you keep it within a certain number of versions of the current version. Okay, so that's a big difference. There are a couple of other parameters, but that's about it. It's very, very lean. Once you do that, okay, that environment will get a default domain. Okay, so that's the environment there. So it just makes up a unique environment name. The region where you've deployed it, in this case, Canada Central, and then the container apps end part of the domain. So that's going to be important in a minute. So now that we've got our environment, we can actually deploy some apps into it, or microservices. So the first one I'm going to deploy is the .NET one, because it's the back-end one. And again, you can see not too many parameters, really just a link to the container image we want to use, where we want to deploy it. But the really important thing here is we're just going to tell it ingress internal. So don't expose this to the internet. And what that's going to do is generate a FQDN that looks like this. So we're going to have our app name. It's going to have .internal. It's going to have the environment part that we created before, the environment, the region, and the container apps. So this is an FQDN that our front-end app will be able to use, but no one from the internet. That will not resolve publicly. We'll see that in a sec. So now that we've got that FQDN, we can actually deploy the front-end app, which you can see looks almost exactly the same. The big difference here is two things. One, we're going to tell it to expose that externally. So sort out that ingress for me, please. I don't want to have to worry about that. And then the next line there where it actually, we're going to pass through an environment variable to give it the .NET FQDN, so that internal name, so that it can call the back end. And it's going to end up with something looking very similar to the front end, just without the .internal part. So that's sorted out all that kind of things for it. And you'll also notice it's sorted out certificates and things like that. Once we do that and we hit that front end URL, in fact, let me without any risk at all, jump over to the actual website. So here's the thing. Let's just refresh this, make sure we're all good. So this is the wonderfully complex and colorful sample app. This is the front end one. And all it's going to do is when we click the little button here, I'm going to call a method on that container, which is then going to pass that through to the backend one and basically just display whatever the heck string that thing did. So we're going to do that, pass it through, it'll warm up. There we go. These have been sitting there cold for half an hour or so. But in fact, while that's waiting, if I do this, kill that. Now, if I hit this page, you'll see it's coming up basically instantly because there's at least one container there now. Okay, we've hit the button and now we've hit the back end, and in very typical programming style, it says hello from the .NET 6 container. So that's actually, that message is coming through the ingress into that front container, calling the back end container and coming back. And if I just keep refreshing that, you'll see the message stays the same and it's just coming back and forth. Awesome, very, very simple. Can find the button, there we go, which is what the screenshots you see there. We go. Okay, and if, oh yeah, I didn't show that, but yes, if I try and hit that internal FQDN, no thanks for coming, try again later. So quickly, let's just kind of run through the concepts here. Obviously, we talked about the environment. And the environment is the abstraction of all the things you would deal with Kubernetes. So it's the cluster, it's the VNet, because all the apps and all the microservices within the environment share a virtual network. They also share the log analytics workspace, which I mentioned before, and they can all be deployed into that. So that's the concept of an environment. Super lightweight, but you can imagine thinking back to Kubernetes under the hood. We talked about exposing that ingress. There was an Envoy container that was configured and managed for us. When we deployed those FQDNs were generated, the certificates were generated and installed, and all that wiring up that you would have to do yourself with Kubernetes was done automatically by the service. So the reason to put things in the same environment is obviously that they want to talk to each other or they're related to each other in some way. Typically when you're running in a Kubernetes cluster directly, you'll often get multiple applications deployed onto the cluster that aren't related, but you're doing it to make use of the compute that you're already paying for. Obviously, in a serverless model like this, that's not really relevant because you're only paying for the compute that the containers actually deliver. So much like you would with an Azure function, you just, you can have as many environments as you would like that represent the boundaries that really make sense. The containers themselves, as I mentioned, are just regular containers. Each, just like in Kubernetes, when we deploy an application, that may actually consist of more than one container. Using a sidecar pattern or anything else, there may be some associated containers that run in a pod just like they do in Kubernetes. But again, you don't see it. You just describe in the manifest file what you want the application to consist of, and it will manage the life cycle of the containers. It'll do all that. If things die, it will restart them. When we specify scaling rules or memory requirements that we want these things to have, that will apply to all instances of those containers. Another important concept is revisions, because one of the big challenges with microservices is how do you roll out new changes without breaking things. So every time you update the definition of the app, or you publish a new version of the container, it will automatically create a new revision. And you can configure some policies around how that happens. Do you only ever keep one revision? Or by default, it'll keep the last 100 revisions before it starts throwing them away. Or you can explicitly activate and deactivate revisions. So this is particularly handy for A/B testing, if you want to compare how one thing versus another, but also for blue-green deployments. So when you're rolling out a new version, you can roll that version out and then cut over a percentage of the traffic. So we might say, okay, let's send 5% to the new version. Yep, everything still looks good. Okay, let's go 10, 20, 30, 40 until you fully cut over. And if things go wrong, you can always roll back. So it makes that very, very simple. We'll have a look. I'll show you a little demo of that in just a sec. And ingress, we've already kind of talked about this. So that's basically all the Envoy is the solution that's providing all of that for us, including TLS termination, support both for HTTP 1 and 2. And you can also configure, for example, do you want non-secure to redirect to secure, or do you just want to drop non-secure connections? So there's some configuration options for you there, but not a huge amount compared to what you can tailor if you were deploying some of these solutions yourself and managing them yourself inside Kubernetes. And I guess the last thing here is really the CI/CD part of this, which if you've ever used things like Azure App Service, it has super productive, super lightweight integrations for deploying things. And container apps is the same. So in the example I've got here, I'll show you in a sec. I've set this up using GitHub Actions, but you can use it whatever you like. But it's all kind of baked in terms of publishing revisions, managing all this, and switching over. And lucky last, oh no, I tell a lie. Second last, so secrets management. Again, there's a lot of options. Kubernetes does have some secret management capability, which is anyone who's looked will know it's not really that secret. So you would typically include some other kind of security mechanism there, be that Azure Key Vault or Terraform Vault or something like that, which you would connect into Kubernetes. But that's managed for you here in that. And now we're getting to lucky last. Logging and monitoring. So as I said, there's lots of options you could use for that in Kubernetes, but in Azure Container Apps, it's log analytics, and you can then integrate that into other things, but it's all wired up for you. Log analytics, there you go, good, done, and out. So just to show you what this, this use case of using revisions, because that's a very, very common developer scenario, and it's one of those things that's very, very simple, but as your microservices get more and more complex, it can be a significant pain point. So in this particular case, we're just going to have a look at an example of how we could split a percentage of the traffic between the current version and the new version. So by default, the policy will assign all 100% of traffic to the latest version. Okay, you can see the old ones are there. I actually forgot, apologies. I didn't name my revisions. Typically you would use that, some kind of versioning scheme you use. So it will just generate a unique name for you, which is kind of okay, but it's, can be a bit tricky to tell which one's which, but regardless. So you can see here, we've got 100% of traffic, and literally it's as complex as going, okay, I want 50% to go to this, 50% to go to that, and away you go. And that's literally versioning. So let's go and have a quick demo of that. I'm just monitoring time. Going super fast because this is really exciting. Okay, so we saw here before, as we kind of kept it refreshing this, we got this message, hello, from the .NET 6 container. Let's go into our sample environment, go and look at the apps. So I've only got a couple in here, and I want the backend is .NET, yes, .NET app, and you can see here's our URL, here's our environment, here's our link to the log analytics. I'll just show you this while I'm here anyway. Obviously, we deployed through the Azure CLI, but if you're coming through the portal, you can configure those same things. Do you want ingress? So in other words, do you want this thing to accept HTTP traffic, even if it's internal or external? Because, for example, in a scenario where you're reading from a message queue in response to an event, you actually don't need ingress because it's the event-driven thing that's going to do it. Then do you want the ingress visible to the external world, yes or no? So pretty straightforward. We want to have a quick look, though, at revision management. So here, this is our current one at 100%. This one here is actually newer. And I've I invested a huge amount of time changing the message ever so slightly. So switch those to 50%. Oh, there we go. I'm going to click save. Now, obviously, in real life, you would do this as part of your CI/CD pipeline, but that's all right. I don't often do things in production, but when I do, I use a GUI. So that saves, it takes about a minute or so from past experience for that to save that thing. There we go, that's done. Now I'm going to come back over here and I'm just going to hit this a few times. So hello from the .NET 6 container. And now I'm suspecting now we're being redirected to the new container because it's cold starting. It takes about 10 seconds. Oh, mouse, come back. Let me just make sure I did that to the right one. Yes, I did. Good, 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 good. Oh, now it says hello again from the .NET container. I told you I invested an awful lot of time. And as we keep hitting this, we'll kind of 50% of the time, hopefully, we'll get one or get the other. So again, really simple example, but something in Kubernetes, you will have to figure out or select a product that will help you do things like that. So yeah, so all about super lightweight, super opinionated, just get you to the developy part as soon as possible. Oh yeah, so CI/CD, as I can just make this a bit bigger. There we go. Yes, in real life, obviously you would do this with some kind of CI/CD set process. Let me just jump back over here. So in if I go over to GitHub, so this is actually being deployed not via those Azure CLI commands anymore, but via GitHub Actions with Dapper. It's actually using, and in fact, let me show you that. So it does all its usual thing. It's actually using Bicep. The examples provided are actually in Bicep, which I find much, much easier to read. And yes, just deploy those. And you'll see if we go to the container app deployment, it's basically specifying the exact same few properties we saw before. So not particularly complex. So last thing I wanted to touch on. So that's great. That's got us to the point of deploying microservices quickly. We've got a whole lot of the wiring done for us around ingress, around secrets management, around logs and monitoring, which is great. But there's still a little bit of the journey to go for being super productive with microservices. Let me flick this back over. And that's where Dapper comes in. So Dapper is not unique to container apps. It's a separate product. You can run a separate project. You can run it, on virtual machines. You can run it in AKS. You can run in any kind of cloud offering around that. But there's support for it built in within Azure Container Apps, which is fantastic. So what it does is provide a whole lot of the building blocks that you need to build microservices. So, for example, one of the classic cases there, service-to-service invocation. So remember I said at the beginning, one of the challenges with using, say, Azure Functions as a microservices platform is, if you deploy a new function, you need to basically provide that FQDN or the actual URL to that function from one to the other. Now, where we've got to so far in container apps, you still need to do that. Sorry, I was going to show that and I forgot. If we think back to our no, I want this one. This one. So remember we passed into the front end app, we passed in the FQDN of the back end app. So we haven't actually solved that problem yet, because even though the FQDN is created for us and whatever, we're still dealing with all the services having to directly call the other services. That's service discovery. We don't want to have to deal with that. So what Dapper does, it provides a way for us. In fact, somewhere here, there's a really nice little picture. Here we go. Okay, so what Dapper does is uses that sidecar pattern. So when we deploy service A, or in this particular case, container app A, so the front end, it gets another container deployed into the pod, which is the Dapper pod, sorry, the Dapper container. And service A, so in our case, the Node app, when it wants to talk to service B, the .NET app, it doesn't directly call the service, it calls that sidecar sitting right next to it. It says, hey, I want to call the .NET app. And Dapper goes, yeah, I'll get that for you. So basically from service A, every single call is to localhost, right? So it's just calling the container right next to it. As you deploy new services that have been Dapperized, the Dapper framework will actually take care of advertising those, resolving the names, so your services don't have to worry about it. As I said, this is not unique to container apps, but you need to deploy and configure these normally. It's already built into Azure Container Apps. Lots of good stuff. It also brings the other one I will highlight. Oh, there you go. Look, it actually, I knew it had a diagram. So yeah, so all your service to service calls are now just to localhost, which is really confusing for me the first time I read that. But yes, it's basically calling into the sidecar. It will then run off and do whatever it's got to do. The other great part of Dapper is components. So forget our services for a second, but let's say our service wanted to store something, like it needed to store some state. And if I'm in Azure, I might want to do that in Cosmos DB, or I might want to do that in table storage. But if I'm in AWS, I might want to do it in Dynamo or Redis or whatever the service might be. And that service might change over time for different reasons. So with Dapper, again, you can just say, hey, please store that for me in this state store. And Dapper knows how to talk to all these different state stores. So I can completely remove that dependency from my application and just talk to Dapper, and Dapper will go and talk to the right thing. And the same thing for all sorts of services that are very, very common and handy when we're building microservices like PubSub. So do we want to switch from Azure Service Bus to AWS SQS? Great, go and do it. Or RabbitMQ, go and do it. So that provides that flexibility. So that's where Dapper, combining Dapper with the Azure Container Apps, very, very handy. And yeah, that's kind of what we spoke about, I guess, so that within our environment, within our container app, we'll have the two containers within the pod, and that just makes all that magic happen. And we'll just skip past that. All that kind of good stuff. So I think not too far over time. That's where we've kind of ended up. So I guess the highlight message there is Azure Container Apps is now in public preview. It is in public preview, so that means it's still evolving. It is I found it to be very stable and very easy to get started with. There are some limitations at the moment to be aware of. So it's available in about I think 7 different regions around the world in public preview. There is also a limit, which I didn't realize. You can have a maximum of 2 environments per subscription during public preview, which caught me out a few times. I didn't realize that. So that's just something to be aware of, but that's sort of the reality of public previews. Where it fits, as I said, if you want a fully managed platform, you can think of it Azure Web Apps as being, you can keep using that for your HTTP web apps that are relatively straightforward. They're not microservice type applications. That's where that fits. You got function apps and all those other serverless things where you can build your own. You've got things like Spring Cloud and Service Fabric, which are very opinionated about runtimes and programming models. But if you want something that is unopinionated about the programming model, the language, and the runtime, then on one hand you have AKS, which provides all of that, but has a lot of customization and configuration you can do. The downside is you have to do a lot of customization and configuration. Or you now have Azure Container Apps, which provides the same options in terms of freedom of runtimes, languages, etc., but takes care of all that administration for you of the cluster, but at the trade-off of not having as much control over how the cluster is configured and runs. So that's kind of our spectrum there, and that's kind of where it fits. And again, putting on my developer hat, I'm very, very excited for this service. This is kind of what I've been waiting for a long time. This does not in any way replace Kubernetes or AKS, but there's a lot of scenarios where people just want to build microservices or web apps, and the simplicity of it, the scaling to 0, will make it super, super interesting. That's it. Go out and build something and have a play with it. There's some great demos in the doco that Jeff Holland has put together. Some much more complex ones than what I've showed in that Hello World app. There's some very, very simple, typical e-commerce type scenarios, which are great because they tend to touch on a lot of the points, like, you have to worry about state management and storage and all sorts of other good stuff. So that's there. So yes, I'll pause there. And if there's any questions, please shout out.
Todd, I think the session was, first of all, very, very good and very, very informative. And I have a couple of questions, sorry, which I'm pretty new to the container world. So I'm not well versed with all the possibilities and all the things. But a simple question, I work as a solution architect. And now suppose if I have to work, I'm creating a microservice in .NET API, in .NET Core. Now I have an option. I can go for a function app. I can go for a API app, an app API, or I can go for Azure container instances. Now, I know that you touched on some of the points, like, for example, in Azure function, you have to give the URL, but I can put an API management layer in front of it and do something about it. But what would be my reason of, if I give you a scenario of saying that you have this Azure API app, which is on .NET, what would be your decision criteria of going from Azure function or app API or going towards the Azure container instance?
There's probably a number, and look, I guess that's the classic question, right? And that's kind of why I wanted to structure the talk this way. There isn't going to be one answer. To me, it's not so much about where do I run a container? Because if you're just running a container, it doesn't matter. You could put that container in Azure Web Apps, Azure containers, it doesn't matter. The reality is we build apps that are composed of multiple of these things, whether it's a microservice or not, right? We have a container. So I guess the things I would be thinking about is, how do I want to manage, deploy and manage the life cycle of that application holistically? Because, for example, if I deployed it just as individual components, so for example, I could take that same containers that I just deployed into container apps, and I could deploy them into Azure container instances. So it doesn't provide any of that modeling. I can do that. That will run fine. I could take them and deploy them into Azure App Service, and that would be fine. But for now, let me think about, okay, I want to manage revisions of those apps. Okay, I want to deploy a new version. How do I do that? In container instances, I would deploy a separate new one, and then I would have to put something in front of it to, like you said, it could be API management, it could be a load balancer, it could be, depending on what the scenario is. But I would have to put that in, just like I would in Kubernetes. I would have to put something in, and then I would have to find some way to create some rules to manage that traffic. So if I want to do that, and I have some good tooling around that, then that's awesome. If I don't, if I just want to deploy my app, I don't want to have to spend time on managing that. That's where something like container apps is going to be very, very attractive. So my suggestion would be, have a look at them for a start. It's really good. It's a great way to get started. And it's a lot easier there's a lot less concepts to understand than there is in Kubernetes.
Yeah.
But it will come down to, you might have, but on the flip side, you might go to Kubernetes because no, we have super important regulatory requirements or cybersecurity requirements that say we must be able to use an F5 as our load balancer within the cluster, or whatever, or an Nginx, or whatever it is. If you need to turn all those dials and move those knobs, then container apps is not going to be for you, right? It's going to be something like an AKS or an OpenShift or something like that. So it's finding that it's kind of like the classic trade-off of PaaS versus serverless versus IaaS. It's kind of like IaaS has gone away now. It's somewhere in infrastructure architect just fell over. But from my point of view as a developer, I'm not even thinking about IaaS, right? That's a legacy thing I'll use if I have to. I'm really now thinking about PaaS versus a container approach. And if I'm using a container approach, am I going to use a managed one, or am I going to use a serverless one? That's kind of where my thinking is. So I don't have a solid answer, but that's kind of the thinking process I'd be going through around it.
Yeah, that makes sense. From the like, for example, from feature-wise, Azure Function and Azure container apps that we talked about, Azure Function app and the container app. I thought like both of them are providing both serverless facilities, right? And both of them we in function app also we can do blue green deployments. You have got slots or something available in which you can, do you can have different kind of slots available there as well.
If it's deployed in app service, there is some. So the way I think about this is container apps is very much, I think, based on the experience of building app service. Azure App Service I love because of, if you think about it, at the end of the, initially app service was just like almost like a managed IIS and then later Apache service.
Yes.
And it does that. But what makes app service great is all that other stuff like slots, right? And that things like that. So I think this is kind of in my head, this is not the official Microsoft line, my head, I'm thinking of container apps as kind of the next evolution of app service where it's providing that kind of really developer friendly, I don't even want to think about the infrastructure type thing, but for building microservices and containers specifically. There is overlap, but that's, to me, that's sort of where it fits and where that'll be its strength.
Awesome. Thank you very much, Todd.
Welcome.
Hey Todd, maybe contrast a little bit of the new, the name escapes me, the new offering around where it has static content and functions built into it. What was that called?
Static app.
Static sites.
Yeah. So
maybe contrast that with this one would be a good one.
Yeah, that's a really good point, actually. So again, and I've done this, right? Before that service was around, how would you build a static website on Azure? Well, you need some blob storage to store your content. You need something to do the APIs, which would probably be, say, Azure Functions. And then you also needed some way to manage certificates and things like that. So often you would actually use something like the CDN service to do something like that, right? So they're the building blocks. And then really static websites is a higher level service built on that and it also provides some features which help with the management and operation of that environment, right? So you got the building blocks, and then it's kind of wrapped in a higher level service. So, but it's for a very specific use case, right? It's for serving static websites, and it's awesome for that because it's built in. It's already got that. Container apps is a similar idea that it's built on top of the build. So you can probably imagine, and I don't even know this, but I'm assuming under the hood, there's something like, we know there's an AKS type cluster. We know there's going to be those virtual kubelet ACIs to help with the scaling, and it might be Key Vault for managing the secrets and all those things. So again, it's taking some Azure building blocks, but then wrapping it in a higher level service so you don't have to worry about how those blocks work because you just want to deploy your app onto it. So in that case, I'd say that the difference is really around the scenario. The model is the same, but the static web apps is serving static web apps. This is going to come into play more for building just microservice architectures more generally, but also those event-driven things. So for example, processing messaging queues and things that you might before have had as a couple of functions that sit off to the side and process different queues. Now you might actually package those up together as a container app, which actually does a lot of that back-end processing. So you might have a container app that's monitoring a queue and a related one which is monitoring a change feed in Cosmos, and it does some things, and you can manage it in a shared security boundary. It's still serverless, so it's only costing you while it's running and things like that, but you can kind of manage and orchestrate it a little bit easier because it's a higher level abstraction, if that makes sense.
I think that's a perfect example. Like that's an example where it's a clear win above the other options. When you get into like, I just got a simple website I want to build, it's like, there's lots of options. It's like, maybe stick to something normal, but if you got something that, I don't know, and I could be wrong on this, I look at app service and I go, man, that's my go-to. If I've got a simple website, SQL Server, and I'm just doing, it's pretty much the 70 or 80% of the things that are built, that one fits in that bucket, no question at all. But that example that you gave is an amazing example, because app service doesn't do that other stuff real well at all. And when you're doing that other stuff, app service may not be the right tool for the job. You can kind of make it work, but it's probably not as nice as a containerized solution.
Yeah, and I think that'll be the challenge. Amongst all these things, there's always going to be this overlap, right? And so it's the figuring out what fits best, and there may not be one. And we're architects, right? So 3 architecture probably gets 6 opinions.
That's right.
But I think more and more, I think the trend we're seeing is these sort of things are really, like the static web app. It isn't forget the Azure one for a sec. It's a pattern, right? It's an architectural pattern. What we're seeing now is, actual delivering those patterns as a service almost that you can build on. And if it fits your use case, great. If it doesn't, then you just go down one level of abstraction. And one level of abstraction, you go down to the point that makes sense for you. So it's not like use that and never use Kubernetes or never use app service. No. They all have their sweet spots, and it's about just working through that process.
Yeah, that's perfect. And I love to see that scenario, or that how you've articulated that, where you go, this is a clear win scenario. It's like, as an architect, you're often looking for, well, what is that hammer or that nail? I don't know, whichever it is at the time. And you go, well, this is easily the solution, but does that fit the business context at the time? And sometimes it does, sometimes it doesn't.
And absolutely. And the other thing I love about this is it is a two-way door, this service, right? So you could, unlike, something like Service Fabric or, some of the other modeling frameworks, they have a model. They deliver the value by, you buy into that model. With this, what you're deploying are still just containers and microservices in containers that you can pick up out of this service and go and deploy it in a Kubernetes cluster. You're not locked into this thing. You've still got that portability, which I think is key, right? Because there'll always be something better tomorrow. So I'm looking for those two-way kind of things rather than a one-way investment, because then it's, it might be great, but there is a trade-off, to that.
Recently, I was in a similar conundrum of what service to go for, what compute service to look for. I stumbled upon this. Is it okay if I just share my screen?
Yeah, sure. Before you do that, I'm just wondering if I should stop the recording or not.
Yeah, that's fine. Yeah, no.
Unless Chloe, you're happy to have this on a recording?
That's fine. Yeah, that's fine.
Yeah. Okay, well, I'll leave it run then, because it might be of interest to somebody who sees this later then.
Oh yeah, that's okay. Yeah. So I was going through this article which says like what compute decision tree that you should go for, and I think you guys all would have seen that about virtual machine, Azure Batch. Question, Todd, these Azure container instances and Azure container apps are 2 different things altogether, right?
Yeah, correct. So they're container instances is like Azure Functions. So Azure Functions is serverless compute. It runs one little thing. Azure Container Instances is run this container.
Yeah. Okay. Got it.
So under the hood, I think these things will be used by container apps, but so they're kind of the building blocks.
Yeah.
Spring Cloud. I was trying to remember something. There's another. Spring Cloud's another great one, right? Just like Service Fabric. It's a whole ecosystem, right? If you're into Java and the Spring Boot framework and all that, there you go, as a service. But it's only good if you're into that, so this is where it comes in.
Correct. So if Azure Container App would come somewhere near here, right? Like Azure Kubernetes Services?
Yeah, so I kind of have a bit of a love-hate relationship with decision trees like this, right? Because at the end of the day, though, and they're useful, right? They're useful to guide discussions, rather. But I guess what I would start with, first of all, is what is the architecture of the thing I'm building, right? Because I need to understand what that is before I can understand the best way to actually implement that architecture.
Yeah.
Because that architecture will guide you. For example, if we're sort of very event driven and very, maybe whether it's event modeling or whatever, but it isn't a web server type pattern. It isn't a website type pattern. It's more dynamic and more event driven. Then that's going to probably influence me more in one direction than the other. Where I think this decision trees like this come in handy is there are some one-way door type questions, right? So there are some questions that if you need this, it knocks out 5 things.
Okay.
Right. So for example, yeah. So I think these are really useful for that. But I think I use these as I was going to say take them with a grain of salt, but that's not what I mean. I mean, they're a useful conversation to have. And then you have a lot of conversations and you put them together to make a decision. I don't think you can just take this to decide. And look, this won't include. So for example, on here, we can see, how do we get to here? So let's say we're going to get to app service, right? We'd go across there and say, okay, are we building new? Yes or no?
Building, yeah.
Right. Do you require full control? Yes, virtual machines. That makes sense, right?
Yeah.
And then even though it looks like a flow, these are really kind of decisions. Is it a HPC workload? That's a really specific, and this is what I was talking about of kind of patterns and use cases. If you want to do that, there's really Azure Batch is like, yeah, hands down going to win, right? Unless there's something weird. But this next one, microservice architecture, no, then it says go to app service. You could argue that. Now let's think ahead to now we have Azure container container apps. If you say yes, where's it going to go from here? Because this is where it gets more complicated, because event-driven workload with blah, blah, blah. See, and this is where, to me, so event-driven workload could be an Azure function, or it could be a container app, or it could be that.
Yes.
I think there's probably, just like up here where it said, we had this great statement that said, do you need full control? Yes or no? To me, this is where in a decision tree, you need to revisit that and go, how much control do you need?
Honestly, I think after your app service question,
yeah,
even that app service question is kind of, but it gets really muddy.
But look, it's a catch-22 because people always ask us for decision trees, right?
Yeah.
So we produce decision trees, but they're great, but they're not black and white, right? They're just
there's more nuance involved.
Yeah, there's more nuance, but I think they are very, very good. Like these are good things to have with a developer and an infra person and a whoever, and have this discussion to go through it together, because it creates arguments that are really insightful, right? Because a developer is going to say, yes, I want full control. And the infrastructure guy is going to say, you're not going to have full control. It actually provokes interesting discussions, and then you can figure out where to go to.
Yeah, that's a good point.
Yeah,
there's a lot more nuance in this decision tree lets on, and I think after your app service question is like, that question should be framed differently. It's like, it should be more, can you run this on app service and is it going to give you a good result? And if the answer is yes, just go with app service. It's the simplest thing that Azure has to offer, and it's the most used service that I've seen. So stick with common, well understood before you choose to branch out.
Yeah, I have a concern. I was also thinking a similar thing, but if you think about it, if you compare between app service and function apps, in function app, you can, like, suppose you're exposing 4 or 5 functions, you can easily see and immediately that there are 5 functions available in function app. Whereas for an app service, you'll have to implement something like a Swagger or something in order to see what all the functionalities are there. Isn't it like function app seems to be a better alternative to an app service?
Not at all.
No, I think they're very different use cases, right? Because an app service is literally, and it said, it come back to the scenario. The scenario for an app service is to serve websites or web or APIs or web apps, web patterns, right? Now, a function might also be part of that, right? But it doesn't have all the rich, like if you go into the Azure portal, go and pull up app service and have a look on the menu that you get for a given app service, look how many features and functions are built into that thing. It's amazing the stuff you can do, right?
And to that point, like functions can be served out of the app service anyway.
Yeah. And
so
that's where it also gets challenging, because
murky.
there's and that's why I kind of made the point at the beginning that serverless, there's the serverless as a programming model, and then there's the serverless as a hosting model. Because you can take an Azure function and run it on a VM. Is it serverless?
Yeah, it's a good question.
Okay, I can run it in a container, I can run it in Kubernetes, I can run it wherever. So it depends on the lens you're looking at. But again, I think to me, personally, the main thing is what is the use case? What's the pattern I'm trying to solve here? And and then I'll use things. So if it's going to be a website, then something like app service or now container apps makes that a bit harder, admittedly. But it's got all these great features that suit that workload as the front end for the website. Now, what's the back end for that website? That could be Kubernetes, that could be Azure Functions, it could be all of those things. That depends. But as there's a lot of problems in managing and looking after and evaluating and monitoring websites. That is, if you just use app service, it's out of the box for you. If you do it with Azure Functions only, then you're going to have to think about, how do I monitor my website, which is all those different functions, right? Which is why we have things like the static web app service, which is built on functions, but it's trying to wrap it around the common patterns and problems that deal with serving.
And even in those scenarios, it depends. Like, it absolutely depends on the scale, the size of the solution. But often doing a lot of websites hosted from an app service, it's just the simplicity and the cost reduction in developer effort versus going to some of these other models. If you're building a big website and you've got a lot of money to burn, absolutely explore the other options. But if you're doing something that's, it's less than $1 million, you're going to kick this thing out really quick, it's often not even worth thinking about.
Don't get me wrong, but I have been working on app services like day in and day out. I prefer app services because the way we have been working like web APIs for long. Now, some days back, somebody challenged me that why not you do this way, and I didn't have an answer to that question. I was like, okay, this is a valid point. I can pose the same thing here, but like, why or why not? I didn't have the answer to that question, and that's why I asked you guys, like, why? Or why?
It's great.
That's a very good question.
It's
certainly
no
like
wrong question, right?
And I think the key to this is you kind of get to the point where you need to build good muscle and process for evaluating these things, not once but ongoing, right? Because the services keep changing. But again, that's why things like app service is great too, because there's nothing really in terms of your app that locks you into app service, right? It's really not aware of app service. There's definitely deployment process and operational process that would change, but I could take that same app that we deployed in app service, and whether it was containerized or not, I could then containerize it and stick it on, container apps, or I could stick it in Kubernetes. There's nothing, you're not buying into a whole lot of overhead, not overhead, but things like Service Fabric, you're buying into a whole programming model, not just a service. The same for the node stuff, the same for a lot of things, right? So if you're gonna go into those, you go into that, and that's great, but you're kind of invested. Whereas a lot of this other stuff now, you've got portability. I can go from app service. Functions is different. I can't necessarily go from, if I've just written a normal app service, I can't deploy that on functions. I can deploy functions on app service, but I can't, if I've just built a web API, I would have to rewrite that as an Azure function. It's not a huge amount of work, don't get me wrong, but it is rework, whereas some of these other models aren't. So it's just trade.
I just want to reinforce exactly what you're saying, Todd, is like, especially with .NET 6. It's like, if you're using .NET 6, Node's a different kettle of fish. If you're using Node, go containers, it's a no-brainer. But if you're using .NET 6, well, all of a sudden it's not a no-brainer, right? .NET 6 has a lot more decoupling than other technologies, so it sort of makes it hard by being easy because you can now choose a lot more things. Because .NET 6 is super decoupled, especially if you're doing the framework-dependent compilations and single-file compilations. It's just like it's a really elegant solution, .NET 6. So that's totally my opinion. It's like it just seems really amazing how they've been able to, decouple all of your dependencies. There's no more .NET runtime. There's no more .NET Core runtime. It's all just native. So now you've got a single file that you can run a website from. It's like, okay, that's pretty cool.
And all it took was 2 years of huge amounts of work.
It's definitely worth it. I'm happy. You can feed that back.
The other thing I was going to say, though, if you do like functions or you're interested in microservices, also I'd strongly recommend go and have a look at Dapper. Dapper is really nice. The other thing I like about Dapper, so the things like all those bindings to the components, it was developed using a very similar model to what the input and output bindings in functions were. So it's a really lightweight way to do things. So that's definitely another thing I'd check. Doesn't tie you to any particular service.
Is this 3 years now, Todd, or 4 years that you've been talking to me about Dapper and trying to bend my ear to Dapper, and tonight I've finally seen the light. It's like, okay, service discovery, I'm sold.
To be fair, we had I remember we had a very confusing conversation because you were thinking of Dapper, the ORM.
Yeah, no.
There's another tool called Dapper, which is an object relational mapping thing, and you were thinking that, and I was talking about something else, and then eventually went, oh, you mean something different.
Yeah, now that I know he's not trying to replace Entity Framework, it's like, okay, he's back on my good books. We can talk about Dapper now.
Is Dapper the equivalent of Docker containers?
No. So Dapper is like a framework for building microservices. You can deploy it. It can use containers. It doesn't need to use containers. So
service discovery and decoupling. Can we go with that?
Yep. So it's like if you think of when you want to build microservices, there's a whole lot of common problems everyone has to solve, and that's what Dapper is. It's like, here's the building blocks to making it easier to build good. Well, that certainly it works for microservices, but obviously they're talking more generally about distributed applications. But for the most common thing, microservices. But it's and it's not perfect for everything, because the one thing that it still challenged me was, like, it's got all those bindings, the component bindings. So if for a messaging queue, you could use Service Bus or AWS SQS or RabbitMQ or whatever. And so there is an element of, well, it obviously doesn't support all the advanced features of all those things because they're all so different. You couldn't have a common interface to those. So there's always a trade-off, right? You lose some of that. The advantage is that A, you get portability, and B, it's the usual thing. 80% of the time you probably only use 20% of the functionality in the service bus queues and whatever. But the other nice thing I like about Dapper is that you can incrementally adopt it. So you can do a lot of it, and it's completely invisible to your app. In fact, the usual change you have to do is pull stuff out of your app, stop doing all that work, and it's just a configuration that sits out here. But again, it's no one solution for everything, but it's particularly when you're getting started with microservices, it's I think a great place to start, because it puts you in a solid place to begin with.
Righty. And for container instances like the Docker, the images and all, you generally guys use Docker images only, or do you guys use something else for containing?
They're actually not Docker anymore, but they're OCI, right? There's a standard for Docker. Okay. There's a standard for container images, and it's called OCI, and it supports that, which everyone calls it Docker, because Docker didn't invent containers, but they certainly made it popular and easy. But yeah, you can if you can deploy that container to Docker, you can deploy it to any of those services.
Cool. Yep. Thanks.
Cool. All right.
All right. How are we going?
All right. Should I stop the recording now?
Yes, I think you can do that. That was a good chat, though.
Yeah, it was. Definitely. All right. Stop recording.